All right, everybody, so it seems like everybody's struggling with opening the program. So I'm going to show you on my computer how I'm doing it. This is the lab report that I assigned. If you click on that link, this is the window that pops open. I'm going to click on vessel resistance for cardiovascular dynamics. And here's the window that you should see. This is your heart. This is any organ. This is the vessel in between. That's going to take the blood from the heart to any organ. And we're going to manipulate the pressure, radius, viscosity, and length one at a time and see the effective flow. So first we're going to look at activity 1, which is the effective radius. We have our pressure set at 100. We're going to change our viscosity to 1. And our length stays at 50, and our starting radius is 1.5. And then we hit start. A lot of this is just a watching game, just waiting. Okay, that is done, and then you hit record data. So that is your first data point right there. This is that first column. So you'll see you'll record 4.4 as your flow. Then we change the radius in increments of 5 millimeters. So we're going to change it to 2. Oh goodness. Really? There we go. Refill and then start. So just this little change in radius actually makes the flow faster, right? Because it's an exponential and linear exponential and direct relationship. So we're going to see that the flow went up to 14 milliliters per minute. We're going to record that. Okay, notice how it's flowing very, very fast now, and the actual, the radius of the vessel is actually changing too. Okay, record, refill. We go up to 6 millimeters. Okay, so that is activity 1. What you would do is take all this data and record it in your document here. Okay, then you would manipulate in activity 2. You would manipulate the studying the effect of viscosity. So you would select viscosity. You would change the radius to 5. The viscosity starting point is 1. Oh, goodness. Okay. The length stays at 50 and the pressure stays at 100. Okay, so let's see how a starting point of viscosity is there. Okay, record data, and then we increase the viscosity by 1. Okay, and then we go all the way up to 10. So just to show you guys kind of quickly, okay, so much slower than the first one, right? And you can see that big difference between the first flow rate where the viscosity is 1 and then suddenly the viscosity is 10 and the flow has gone down significantly, okay? And then the third activity was to manipulate the length. So the radius stays at 5, viscosity goes down to 3.5, and we start at the length of 10, and the pressure stays at 100. Okay, so refill and start. Okay, so very fast. Oh no, I didn't record that. Refill. And we have to change this to length. And start. Okay, then we change the length to 15. Okay. I know I jumped by 10 right now. Record, and the last data point is at 50. So again, you can see that the flow from a short vessel length is actually very fast as compared to a longer vessel length. Okay, and I'll send all these numbers to you via email so that you have all the data points that you can fill your data table in. I just wanted to show you the experiment via technology so that even though you didn't get to do it using it, you'll know what it was and what it entailed. Maybe having a visual is going to be helpful to remember the relationships between all of these. Activity 4 was changing pressure. Okay, so you're going to change the pressure now in the artery, basically. So radius is 5, viscosity is 3.5, the length stays at 50, and the starting pressure is 25. Okay, pressure, and we're going to refill, start. It's a low pressure. Record the data, and we increase in increments of 25. Record. Okay, let's jump to the last data point, which is 225. Okay, refill. All right, very fast flow. So here again, if it's low pressure, it's slower flow. If it's high pressure, it's higher, it's faster flow. Okay, that's the relationship you should keep in mind there. All right, so I will send you guys all this information via email, and hopefully you guys will be able to understand what's happening and be able to answer those questions looking at the data tables. Okay, good luck, and please email me with any more questions. Thanks. Bye.